Okay. On Friday, we looked at trig ratios of two primary triangles, this 30-60-90 triangle and the 45-45-90 triangle, in which you were able to get the trig ratios of all of the angles, but left in exact values, meaning that we don't take fractions as a possible answer. We leave it as a square root, 3/2 or root 2/2 or whatever it is, okay? Today, all of this is setting us up for grade 12 when we have to do what we call the unit circle. We work a lot of trigonometry around the circle that has a radius of 1. So today we're going to look at just standard ratios of any coordinates on a Cartesian plane, which is just a grid. All right? So what we're going to look at first is how we come up with the sine, cos, and tan ratios. All right, so what I said before is that we're dealing with what we refer to as a unit circle. So the unit circle goes like this, in which my radius from here to here, or anywhere around that circle, is 1. So if that's the case and I'm on a plane, what does that make this coordinate right here? What's the coordinate? 1 and 0. Okay, excellent. Now, if I pick any coordinate x and y on that circle in the first quadrant, so I'm going to take this coordinate right here and make it x and y. All right? That means then that this distance from here to here is what? Y. And the distance from here to here is x. Excellent. What did I say the radius was? 1. Okay. Now let's say for the heck of it that I don't actually know what that radius was. Let's say that radius was r. Okay? Just any value. I can still calculate the trig ratios for everything going around that triangle. I've set up a right triangle. All right? So if this is sine theta, or sorry, if that angle is theta, what I want to do is I want to find out what is the ratio of it. Because whatever the ratio is going to be what that coordinate is right there. So let's look at the sine of theta then. What is the sine of theta equal to? Well, where's the sine across from this? Y. And what's the hypotenuse? 1. Y over 1. The cos of theta is what? X over 1. Right? The tan of theta is what? Y over x. So what I've done then is I can find any trig ratio of any coordinate on the Cartesian plane. I can find the ratio. And what do I notice about it? Well, the sine theta is equal to y, and the cos theta is equal to x. That means that any coordinate around here, I better leave the first quadrant, is cos theta, sine theta. If I take the coordinate and I make a right triangle, I know that the x value of the coordinate is going to be the cos ratio, if I draw that triangle. And if I draw that triangle, the y value of the coordinate will be the sine ratio. So what happens over here? What changes over here? The x is a negative in this quadrant. It's still negative cos sine y. Now, I can determine which of the trig ratios is positive and which is negative by doing this. Cast. All right, what does that mean to us? All the trig ratios in this quadrant are all positive. The sine ratio in this quadrant is positive. The cos is negative because the cos is the x value. Only the tan one is positive down here. Well, why is that? Because I have a negative over a negative. Sine is negative down here. So is cos. So therefore tan is the only thing positive. What's positive in this quadrant? Cos. Because cos is a positive in this quadrant because it's x. Sine is negative because it's the y and it's down below the axis. So I use that cast to help me determine which one is positive and which one is negative. Alright? If you look at the bottom of that page, 68, they somewhat show you that. Quadrant 1, all ratios are positive. Quadrant 2, sine is positive. Quadrant 3, tan is positive. Quadrant 4, cos is positive. That's how I remember it. The word cast. And I start in the fourth quadrant and work its way up. Okay? So what is the point of this? Let's look at your working example number 1. The point 12 and negative 9 lies on the terminal arm of an angle theta in standard position. Determine the exact trigonometric ratios for sine, cos, and tan. Okay? So the first thing I'm going to do is I'm going to plot that coordinate. So that coordinate is 12 and negative 9. So somewhere down here, agreed? And I want to know all of the trig ratios for this. So to do that, I'm going to create myself a triangle. All right, number 1, mistake that gets made here is you don't draw your triangle with the x-axis. It is always made with the x-axis. So the ratios are all based on that angle right there. Okay? So what's my y value? Negative 9. What's my x value? 12. That's based on my coordinate. So what do you suppose the first thing is that I need to find in order to get these ratios? R. That's right. How do I find R? Pythagorean theorem. Exactly. 12 squared plus 9 squared. 144 plus 81. Make 225, which makes this 15. We agree? Okay. So now I just have to list out my ratios. So what's the sine of theta equal to? Which is?
9 over 15.
No. Negative 9 over 15, that's right. Cos theta? Yeah, which is? 12 over 15. And for once, I'm not so worried about reducing fractions. What's the tan then? 89 over 12. That's all there is to it. So if you look on your page, they set up the graph. You're to graph it, which we did. Then you know x and y. You use Pythagoras' theorem to find r. and write your ratios out at the bottom. Okay? So far, so good? Any questions about this guy so far? What I'm going to do right now is I'm going to give you one more. I'm going to give you one more to do because I'm about to go back and work more on what we did last day, which is to me a little bit more important. Okay, so let's take these coordinates now. -6, -8. So we'll work together on this. Which quadrant is -6, -8 in? Third quadrant. So let's draw that out in the proper quadrant. Where is my angle always made? With the x-axis. Okay? My x value is? My y value? What's the first thing I need to find? R, which is? I'm going to do it quickly. Over the calculator. Okay. Okay? So now, what's your sine ratio? -8/10. Cos? And -8/6, which is, this one I might want to at least do that too. Could reduce it to 4/3, but at least get rid of the two negatives. Okay? And we know that tan should be the only positive thing in that quadrant from that. Okay? Went through that pretty quick. Any questions? All right. Here goes. I'm going to now look at page 70. But I'm going to go and be a little more extensive with 70 right now than what need be. Okay, here's what I need you to do right now. Is I need you to take out a blank piece of paper, please. I need to have a blank piece of paper, and we're going to go through this. Okay, so last week, it's a major here. Last week we focused on the exact values of two very basic triangles. So what we're going to do is we want to find out all of the ratios that work with those triangles and their exact values, which basically means I'm going to fill in a whole circle here of coordinates. Now I'm going to start with the 30, 60, 90 today. This is what we refer to as the unit circle because of, again, the radius is going to be 1 in this case. All right? So the first thing I'm going to do is I'm going to look at my coordinates right here. So what is the first coordinate there if my radius is 1? 1 and 0. So at 0 degrees, at 0 degrees, if what we just learned at 0 degrees, what is my cos of 0 degrees? My cos. No. Okay, let's go back a page. Okay. Looking at this right now. Let's go back even further. What is my cos value anywhere along this circle? The x value of the coordinate. Agreed? X, y. So if that's the case, what is the cos of 0 degrees? Which is 1. What's the sine of 0 degrees? 0. You need to draw this circle up, so make sure you do a nice big circle because you're going to put a pile of information on it. So make sure it's big. Like you need to use almost the whole page. What would the coordinates be up here? What are the coordinates at the top of the circle?
1, 0. Something 0. 0 and something.
0 and 1. At 180 degrees. What are my coordinates?
-1, 0.
Yeah. (270 degrees).
0, -1.
0, -1. So that's the start of this. Now the first angle we're going to look at is 30 degrees. Okay? So on Friday, we learned what the trig ratios are for 30 and 60 degrees. So what is, let's start with the one that we are supposed to know at all times. What is the sine of 30 degrees? This is the one you can't ever forget. Forget already, Jeffrey? Yes, it is. Good for you. 1/2. So that coordinate there is 1/2. Because that's my trig ratio. What's the cos of 30 degrees?
√3.
No, you're close though.
√3/2.
Yeah. It's √3/2. So again, that's the angle made with the x-axis. This is hugely important because all of the first quadrant is your reference angles. You have to know, not so much in grade 11, but in grade 12, you have to know how to label this first quadrant properly because all of the rest of the circle is contingent on what that first quadrant is. So let's look at 60 degrees now. What's the cos of 60 degrees? Got that triangle beside him? What's the cos of 60 degrees? All right. We've forgotten. So watch this. This right here is 60 degrees. Agreed? Yes? And we said that the sine of 30 was 1 over 2. And the cos of 30 was root 3 over 2. Right? Well, what's the cos of 60 degrees here? What's the side adjacent to the 60? So this ratio is 1 over 2. What's this ratio then? What's the sine ratio for it? Yep. Root 3 over 2. Those values for the 30, 60, 90 triangle never change. They'll never change. They're always going to be a half and root 3 over 2. You just have to remember where sine 30 is. Okay? So now let's look at (120 degrees now. All right. What is my reference angle for 120 degrees? 60, Alexon. So if that's the case, then what is the cos of 120? Yes, it is, with one glaring difference. Yeah. So what is it? What's the cos of 60 degrees? It's written up there. What is it? 1 over 2. So, negative 1/2. What's the sine of 120? Up, Jake. Square root 3 over 2. If the reference angles are the same, you're going to have the same ratios. The only difference is because of the quadrant is you're going to have different negatives and positives. So now we go down to 150. 150 degrees. What's the reference angle at 150 degrees? 30. So what's my ratio going to be then? Negative square root 3 over 2 and not negative. Y still positive, right? So it's the same as the reference angle. So we can keep going. Now, 210 degrees. What is the reference angle? It's the reference angle for 210 degrees, Liam. 30. 210 subtract 180, right? 30 degrees. So therefore, what are the ratios for this one? Negative. Both would be negative? That's right. Negative root 3 over 2. Negative 1/2. What's the cos of 210 then? Negative root 3 over 2. What's the sine of 210? Negative 1 over 2. So let's go down here now. 240 degrees. Reference angle? 60. Therefore, what's my ratio?
Negative 1.
Negative 1/2.
Negative
Negative root 3 over 2. Okay? Now let's go down this way. So my next one is 300 degrees. Reference angle? 60 degrees. Therefore, what's my ratios?
1/2 and negative 2.
Very good, Sam. 1/2 negative root 3 over 2. The last of the 30, 60, 90s. 330 degrees. Reference angle? 30 degrees. Therefore,
root 3 over 2.
root 3 over 2, negative 1/2. There's all your 30, 60, 90. Now, I want you to think this through. We did this in applied, and we were talking about ambiguous triangles, where we have 0, 1, and 2 using the sine law, correct? Which happens to be what we're doing tomorrow. Okay? So we're talking about the sine law now. And what was the one thing that we learned about the sine law? How did I get the second angle? You remember? For the second triangle, I would use the sine law, I would get an angle. How would I get the second angle? No. What did we learn about the sine ratio? What's the sine of 30 degrees up there?
Oh, the opposite. Like 180 subtract the sine is the same.
That's right. What's the sine of 30 degrees up there? The ratio is what? 1 over 2. What's the sine of 150 degrees up there? What is it? Is that not it there? Same as that. What's the cos of 60? What is it? No? Oh, sorry. You're right. Cos of 60 is 1 over 2. What is the other angle that has the same ratio as the cos of 60? What other cos has the same ratio as cos of 60? 300. What I'm setting you up for is this second part of this. There will always be two ratios that will give you the same value on this circle. All right, now I haven't done the 45s yet. We'll do that later. But for right now, I want you to get a grasp of the 30, 60, 90. The ratio values, 1/2 and root 3 over 2, do not change around that circle for a 30, 60, 90 triangle. They don't change. All that changes is the negative value. And all of them are the same as whatever the reference value is in the first quadrant. So if it's a 30-degree angle, your values are going to be root 3 over 2.5. All you're changing is your negative signs. If it's a 60-degree reference angle, it's going to be 1/2 and root 3 over 2. All you're going to change is your negative values. And you keep going around the circle. Take a look at page 70. I want you to fill this in right now. Determine the exact values of sine, cosine, tangent for theta equaling 120 degrees. So you draw 120 degrees. What is the reference angle for 120 degrees? 60 degrees, so write that down. The trig ratios for 60 degrees are what? What's the sine of 60? What's the sine of 60? Root 3 over 2. What is the cos of 60? 1 over 2. What's the tan of 60? Nowhere on there did we do tan today. How did I find tan? Okay, how did you get 1 over root 3? Okay, or is it root 3 over 1? All right, I need you to go back. What is tan equal to? Y over x. So now, we're talking about this ratio right here. I need to take y over x. What's y? What's y? Root 3 over 2. What's x? 1 over 2. So I need to take root 3 over 2 over 1 over 2. So root 3 over 2. So this is my tan of 60. Root 3 over 2 over a half. What's the tan of 60? Square root 3. Write that down. Okay? Yeah. Okay, so now look at tan in the square boxes there. In quadrant 2, what's positive? Y or x? So I'm looking at the tan. You notice that they did sine, y over r is plus over plus. Cos is negative over plus. Tan is what? Is what? Positive over negative. Well, look at this here. What's your y value? Is it positive or negative? And your x value? So it's a positive over a negative, correct? Which then means tan is actually equal to what? What's a positive divided by a negative? Negative. So tan's negative. Therefore, what is positive? Sine is positive, and cos and tan are negative for angles in quadrant 2. So the sine of 20 is what? Sorry, the sine of 120 is? Don't use decimals. It's not the right answer either, though. What's the sine of 120? Look at your circle right now. How do I find sine on that circle? No, I asked how I find it. Pardon me? Yeah, but on this circle right now, where is sine located in every one of these ratios? It's the y value. So look at 120 degrees right now and tell me what the y value is. 3 over 2. What's the cos of 120? Pardon me? Again?
Or negative 1 over 2.
Negative 1 over 2. Okay? And what's the tan of 120? We just solved it. What did I forget on that page? Negative. Right? Should be a negative, which means this should be a negative there. Okay? We're going to play with that a little bit more tomorrow. A little bit more tomorrow. So, how many of us, are any of you done 2.1? You are? Okay, then I'll give you, let's look at working example 3. Do not throw that circle away. You're going to need it for a couple days, and then I'm going to give you a nice copy of that circle with everything on it. But for right now, I need you to be able to do it. In grade 12, you need to, and we have to add the 45s to this, which is what we'll start class off with tomorrow. In grade 12, you have to draw that whole circle out and understand it. So we're going to start with this now. It's not part of your grade 11, but I'm going to go through all the ratios with you so that you get a good idea of it now. So next year it's not new to you. Okay? So let's look at this now. Suppose theta is an angle in the standard position with the terminal arm in quadrant 4. So I'm going to draw that right now. So my terminal arm is in quadrant 4, which means then that my reference angle is right there. Fair enough so far? Questions? We're okay? That's what that means. Terminal arm rests in quadrant 4. And the cos ratio is root 33 over 7. The cos ratio is root 33 over 7. Where does root 33 go?
That's the adjacent.
Okay, so where does it go?
On the top. As your x.
Very good. And where does the 7 go?
Hypotenuse.
The hypotenuse. So, there's the cos of theta, root 33 over 7. It asks us to determine the exact values of the other two trig ratios. So I need to find the other two trig ratios. In order to find the other two trig ratios, what do I need to find?
Opposite.
My what? I need to find this right here, right? Okay, which is this squared, subtract that squared, and then the square root. 7 squared is? 49. Root 33 squared is? 33. What's 49 subtract 33? Square root of 16? Is it a positive or a negative? What's your y value? What is it? It's a negative because it's in the negative y-axis.
So how do you know to add those to each other?
I didn't add them together. I subtracted them. Pythagoras' theorem.
Oh, just
Root 33 squared plus x squared equals 7 squared. So, anytime you have a hypotenuse, you subtract in order to get the other side. Otherwise, it's this squared plus this squared equals that squared, right?
Yeah.
Okay, so knowing what I just did here, what is the sine of my angle?
-4 over 7.
Awesome. What's the tan of my angle?
Negative. Oh wait, no. Yeah. -4 over 33.
And we'll just leave it like that. Done. It's a very simple question. And again, this is a question that we're going to see in grade 12 as well. This whole first two sections of 2.1 are all primary and necessary for grade 12, pre-calculus. So we have to do a good job of this. All right? Questions so far? There's a lot to take in here today, so I'm going to do a good job of reviewing with you tomorrow. Solve for theta between 0 and 360 degrees. All right, so this is a unique question. Again, is a skill that is necessary for grade 12. So, here's what we need to do. It says tan theta is equal to -0.9004. We need to find out what the angle is. How do you find the angle of any ratio? What do you have to remember to do? Using your calculator. What do you have to remember to do?
Oh, make it-
Second function, right? So what I'm gonna have you do right now is I'm gonna find the reference angle right now. Right here. So what I want you to do is I want you to punch this into your calculator. Second function 10.9004. I don't want the negative in, I'll tell you why in a second. What'd you get, Jake?
42 degrees.
I needed 3 decimal places.
It's kind of 42 degrees.
Okay. Is that? Is that right? Okay. So, I found my reference angle. But you notice that the tan ratio is negative. What two quadrants is tan ratio negative in? What are the two quadrants that the tan ratio is negative in? 2 and
3, 4.
4. Right? 3, because sine and cos are both positive or negative here, Allison? Okay? So 2 and 4. So I need to find the angle in quadrant 2 and 4 if my reference angle is 42 degrees. Because that will be the ones that give me the negative ratio. So let's do it. How do I find this angle here if I know that this reference angle here is 42 degrees? How do I find that angle right there?
80 subtract 42.
180 subtract it. Now if you recall the other day, I had you write out how to find the angle. In this quadrant, it's 180 degrees minus the reference angle. Down here it's 180 degrees plus the reference angle, and down here it's 360 degrees minus the reference angle, right? Okay, so take 180 subtract 42, what do I get? 138 degrees. So, how I write this out is theta is quadrant 2, 138 degrees. Okay? Now I want to find quadrant 4. Want to find quadrant 4. What is the angle in quadrant 4? That's going to give me that ratio. What is it?
Or like 20.
I want to know that angle right there. Remember, my reference angle is 42 degrees.
318.
318 degrees. Okay, on your calculator right now, take the tan of 138. Okay. Take the tan of 318 degrees. Same thing. Those are the two angles that give you the exact same trig ratio of negative 0.9004. Now what you have to remember is a trig ratio can be given to you as a fraction or a decimal. 1/2 is 0.5, right? So 0.9004 is an actual trig ratio. So you have two angles that give it to you. First thing I did was find this guy, and then I got my two negative ratios by finding them in that quadrant. Okay? I'll go through B after I do the rest of this lesson tomorrow morning. So for right now, those of you that have done 2.1, you could do the first probably 4 questions on page 73 and 74. Okay? It's not much time left today. I'm going to go through this. I'll start with this tomorrow at the start of class with you guys. Got it?
What do you with the square root things instead of decimal.
Say that again, please, Lex.